Hi viewers, yeah, welcome to my channel. Today's topic, let's look at calculation involving change in concentration of the reactant or the product. So look at this equilibrium reaction below. The equilibrium concentration of the species are as follows. So you can see the concentration of COCl2 is 0.055, 0.55, chlorine gas is 0.16, CO is 0.11 mole per dm cube. So if 0.005 mole per dm cube of CO is added to the equilibrium mixture, calculate the concentration of each species when equilibrium is reestablished. Okay, you can pause the video and write this thing down. Okay, so this information is better presented in a tabular form. So let me clean the board so I can have a wider space to solve it. So the equation for the reaction is CO plus Cl2 to give COCl2. So the next thing we're going to look at is the mole ratio. Let's look at mole ratio. Mole ratio. Okay. Although, of course, everything is 1:1:1:1:1. All right. So next thing we're going to look at is initial concentration. So initial concentration of the reactant and product. Initial concentration. So we're given a carbon 2 oxide to be 0.011. So that of chlorine is 0.016. And this one is 0.55 all in mole per dm cube. So initial concentration in mole per dm cube. So next thing we're going to look at is change in concentration. So in that question, we are not given the amount that reacted. So we can select it be what? X. We are not given. So change in concentration, we are talking about the amount of the reactant that reacted. So change in concentration. We actually know it. So let it be S. So let it be S and let it be S. So because reactant will disappear and product is going to what? Appear. So use minus for disappearance of what? Reactant, and add plus for appearance of what? Product. So this thing we're going to look at is equilibrium concentration. Equilibrium concentration. Equilibrium concentration. So we're going to add this thing together. So 0.011 minus X, 0.016 minus S, so 0.55 plus S. Okay. Okay, look at this. So all these are in mole per dm cube. In mole per dm cube. So the next thing I'm going to do is we're going to apply the law of mass action. So K is equals to the concentration of product all over that of reactant. So what's the equilibrium constant? 4.57 times 10 raised to the power 3. So I'm going to substitute these concentrations into this. So the one of COCl3 is what? COCl2 is what? 0.55 plus S. So the one of CO is 0.011 minus S times 0.chlorine 0.016 minus X. So equals to. So I can put this in 4.57 times 10 raised to the power 3. Okay. If I factorize this, the denominator, I will be having this equation. So the equilibrium constant I gave in the equation, equilibrium constant, I put 4.2 times 10 raised to the power. Please change it. It's supposed to be 4.57 times 10 raised to the power 3. Okay, so when you cross multiply and collect like terms, so we have this, we have 4570 S square minus 124.4 S plus 0.254 equals to 0. So this is a quadratic equation. So we're using a quadratic method to solve it. So this is the formula. So I'm going to substitute this value. So this is A, and this is B, and this is C. I'm going to substitute the value of A, B, C into this equation. So S will be 124.4 plus or minus 104.1 all over 9140. So the value of S, we have two values, 0. Which are positive values, 0.025 and 0.0022. So look at this value. The concentration of CO that was added in the question, 0.005 CO was added in that in the reaction. So look at this value. This one is higher than this. So any value you're going to use must be lower than the concentration of what? The concentration that's been added. So this one is lower. So this is a practical value that we're going to be using. So it means that out of 0.005 carbon 2 oxide that was added, only 0.0022 reacted, was used up. That's what it means. The equilibrium concentration will be, remember that in the equation, the tabular form, equilibrium concentration, we got it to be CO 0.011 minus S, 0.016 minus S, and one of product 0.55 plus S. So we're going to substitute the values. CO 0.011 minus X. And what is the value of S? Is this. So 0.0022. So the one of chlorine gas, we have 0.016. So in a nutshell, there is change in concentration of all the species when we disturb the original equilibrium by adding 0.05 mole per dm cube of CO. Alright, we'll come to the end of today's video. Don't forget to subscribe, like, and share this video. Thank you for watching.